Module 7, Lesson 5, we're going to be working to determine the number of solutions. Your suggested pacing suggests this will likely be a 2-day lesson with 17 resources. That's a real possibility. The inquiry question for this lesson asks, how many solutions can an equation have? Now, historically, we've always thought one math problem gives you one answer. But you're going to find that there are some situations where you could have more than one answers in a problem. Now, in this activity, we're going to explore 3 different equations. The first equation, equation 1, is going to be 2x plus 6 is equal to 4x plus 2. And we want to solve for x. So what happens if we were to say that x is equal to 2? So we're going to put in a solution of 2 for x, and when we do that, we're going to find out that, check it, we get 10 equals 10. So 2 is a valid answer for that equation. Now, what happens if instead we chose to use a 5 for that solution? So I'm going to take where I had that 2, I'm going to change it to a 5, and then we're going to hit check, and we have an issue here. We've got an unequal answer here. 16 does not equal to 22. That means that maybe there's not going to be but one answer for this equation. That's the way most of our equations are. Pretty much everything we deal with, you only have one answer. Now for equation 2, they want us to take and enter any 5 values for x. So I'm going to start off with 0. 0 is always a good place to start. We got a balanced equation. Well, what if I start out with 1? If I plug in 1, we still have a balanced equation. If I did 2, whoops, let's try that again. 2, check it, we still have a balanced equation. If I did 3, and check 3, we still have a balanced equation. If I did 4, we still have a balanced equation. It doesn't matter what value I put in for x, we're going to have a balanced equation. And this type of problem is called an identity, which hopefully the textbook will define more later. But in it, you have an infinite number of answers that can go in. So problem number 1 only had one answer. Problem number 2 has an infinite number of answers. Now let's take a look at example number 3, and once again they want us to choose any 5 values to go in here. So let's start with 0. Where x equals 0, we don't have a good answer. Well, what if we change that to a 1? Where x equals 1, we still don't have a good answer. What if we did 2? Where x equals 2, nope. What if we did 3? Nope. What if we did 4? No. No matter what number we type in for x in this one, we have a unbalanced equation, which means that it's not equal to each other. There is no solution, and we would call that an empty set, or theta. I'm not sure if this textbook is going to call it that, but we're going to look into hopefully find that real soon. So we've looked at 3 different types of problems. One type of problem is what you've been working with for a long time, where the problem gives you one answer. The second type of problem gives you an infinite number of answers, and the third type of problem has no solution at all. And you can see that outlaid in this sheet right here. Equation 1, one solution. Equation 2, infinite solutions. And equation 3 had no solutions. The solution to an equation is the value of the variable that makes the equation true. Some equations have one solution, and you can see that in this one right here, it is represented as x is equal to a. Your x value equals one solution. Some equations have no solutions, and you can see that in this one right here, where you have a is equal to b. They're equal to 2 different things. For example, 4 equals 0, there's not going to be any solution. And some of your equations have an infinite number of solutions, and here you have a is equal to a, and the a equals a implies that no matter what number you put in for a, it's going to equal a. So we're going to get a valid solution all the way through it. Now if you look at the structure of these problems, in this one here, both sides are identical. And if you get an equation where both sides are totally identical, 4x plus 2 equals 4x plus 2, you're going to have an identity. There's going to be an infinite number of solutions. If you have something like this where 2x is equal to a number, that's going to give you one solution. And if you get something like this one here, where if you were to subtract the 3x's from both sides, you are going to get two different numbers because the x's themselves will be gone, that's going to be no solution at all. So let's get started with example 1 here, where we're going to solve 6 times the difference of x and 3 plus 10 is equal to 2 times the difference of 3x and 4. We have to determine whether it has one solution, no solutions, or infinitely many solutions. To do that, we're going to simplify each side of the equation and see what it comes out to. So here we go. Diving into it, we're going to say that 6 times the difference of x and 3, 6 times x is 6x, and 6 times negative 3, that's going to be a negative 18. From there, they said negative 18 plus 10, signs are different, find the difference, which gave them a negative 8, so they were at 6x minus 8. Meanwhile, on the right-hand side, 2 times 3x, that gave them 6x, 2 times negative 4, that gave them a negative 8. And when you look at this line right here, you can see that both sides are equal to each other. They're not only equal, they're the exact same thing. And because they're exact same thing, we know at that point we have an identity. We're going to have an infinite number of solutions. Now from here, they went further to isolate the variable, subtracting 6x from both sides. And when they subtracted the 6x's, they ended up zeroing each other out, giving you a negative 8 equals a negative 8. And that gave you an answer that was in the form of a equals a. That tells you once again, you're dealing with an identity here. There's an infinite number of solutions. Negative 8 equals negative 8 is going to be always true because, let's see here, any value can be substituted in to make the equation true. Check it. And it checks. So your answer is there's going to be infinite number of solutions. Which we're going to take and highlight. Nope, can't highlight that. Now it's time for you to work extra example 1 on your own. Isolate both sides of the variable. Come down to a final answer and determine how many solutions. Oh, wait, no, this one has a different thing. It gives you multiple equations to test, so you have to find out which of all these equations are going to have an infinite number of solutions. Good luck with that. Now this one requires a lot of work because you've got 4 different problems you've got to check. First one is going to be, let's get my pen going here, 3 times a plus 3 minus 2 is equal to 1/3 times 9a minus 6. Well, 3 times a is 3a. 3 times 3 is going to be 9 minus 2, which means on this side I get 3a plus 7, because it's 9 minus 2 gives me 7, and that's where I'm going to stop for now. Next, I take 1/3 times 9a. 1/3 times 9, well, 9 divided by 3, that's going to leave me with 3a. And then I have 1/3 times the negative 6. So 1/3, it's going to be 6 divided by 3. That's going to give me 2. So at this point, you can see I've got 3a minus 2 on the right, 3a plus 7 on the left. Those are not identical, so that's not going to be one of my options. Let's try another one. 3 times the difference of 6 and 4g is equal to a negative 2 times 6g minus 9. 3 times 6 is going to be 18. 3 times a negative 4, that's going to give me a negative 12g, is equal to 2 times negative 6g, that's going to be a negative 12g, and 2 times negative 9, that's going to be a positive 18. Now right now those look different, but the commutative property of addition says order doesn't matter when adding, so we can take and flip those two around so that they do actually become the same exact thing. And since they're the same exact thing, B is going to be an identity. The next one we have shows negative 2 times 2x plus 3 that's a minus 3, equals 3 times the difference of x and 4 plus 1. Well, negative 2 times a positive 2, that's going to give me a negative 4x. A negative 2 times a negative 3, that's going to give me a plus 6. On the right hand side, 3 times x, that's going to give me a 3x. 3 times negative 4, that's going to give me a negative 12. And then we have the plus 1. So that one will come down to be 3x negative 12 plus 1 is negative 11. And here we have negative 4x plus 6. And what do you see? You see that those two are not going to be the same, so it can't be a valid answer. Finally, let's do this one here. I'm going to take the 7 and send it through. So 7 times y is a plus 7y. 7 times negative 2 is a negative 14. And then over here, I'm going to send the 5 through. 5 times y is a plus 5y. 5 times negative 1, that's going to become a negative 5. Combine my like terms, so I will get 7y, 5 minus 14, that's going to leave me with a negative 9, is equal to 1 whole y plus 5y, that's going to give me 6y minus 5. Those two are not equal, so that's not a valid answer either. So what are valid answers going to be for this one? Well, it's only going to be one thing. It's going to be answer B. Come down, check our answer, and the answer checks. Easy math, a lot of work, but easy math all the same. Well, the textbook's website crashed on me, so I cannot display the lesson right now to keep it going. So we're going to put the brakes on here and end part 1, and instead come back for part 2 in just a little bit, where we will go into example 2 and continuing our study of how to determine how many solutions an equation is going to have. I'll see you in part 2.